one, and we're live. How's it going, everybody? Christopher Black here, Senior Solutions Engineer with Lacework, doing some really exciting stuff in the cloud security space. And joining me is a longtime friend, former colleague, Sam Arnold. Sam, you want to introduce yourself? Say a few words.
I mean, of all the things I'm most proud of, being your friend has to rank number one. Small number two, yeah, sales professional, enterprise sales. You and I have worked together, specialize in technical products. I am eager to learn about where you are, Chris, and what product you're representing.
Fabulous. Yeah, so a little more context there. Sam and I worked together extensively at Circle CI, another amazing company in the CI/CD space. I think Sam and I have the distinction of closing some of the largest deals in Circle CI's history together. Sam, don't let this go to your head. Sam Arnold is one of the most competent sales professional I've ever worked with. And I think what sets Sam apart from many other sales professionals I've worked with is he is, to say customer centric would be kind of an understatement. I know that, they say this a lot at AWS, but he is customer obsessed. And that's one thing that I think definitely resonates with me. And my philosophy is Sam is always ultimately going to do what's in the best interest of the customer. But if you have an amazing technical product and you're solving real problems, oftentimes things like this just kind of sell themselves. So anyway, preamble aside, super excited to talk with you today about Lacework. Have you heard anything about Lacework? Maybe word on the street? I know some friends who've dabbled with the platform. Where do I begin?
So all I really know about Lacework is that it is a hot, very rapidly growing tech company in the security space. That's really all I know, Chris.
Cool. All right. So I'm just going to start super high level. Then I'm going to show you the platform, and we're going to run through a couple of sample events. So at a super high level, when you think about some of the challenges as it relates to cloud security today, it's fundamentally a different problem set than it was security, than cybersecurity was 5-10 years ago. So imagine 5, 10, 15 years ago, before the proliferation of cloud native technologies, cloud native application architecture, security, not to say it wasn't challenging, it was fundamentally a different problem set, right? Sam, imagine you're managing physical servers. You had 10 physical servers. Some offices had like a server closet. You had physical bare metal infrastructure. You knew exactly what was installed on these servers. You knew exactly who could talk to these servers. You knew exactly more or less what was installed, what the network perimeter looked like. That was very clearly defined. You maybe had a single load balancer. When you think about what technology companies are doing in kind of the cloud native space, it is fundamentally a different problem set, right? Makes sense. Organizations are scaling up and down from seemingly infinite pools of elastic resources. Everything is API driven. Network perimeters are anything but clearly understood. And then when you think about, if you know much about like user permissions, identity and access management in the context of AWS, this can get very, very, very complex very fast. So it's fundamentally a different problem set. I just always start with that premise. I underscore that it's fundamentally a different problem set. And Sam, feel free to interrupt me at any point, ask any questions. I'm here for you, brother. And for our viewers, traditional approaches, should I say, to this problem set are generally kind of untenable, unwieldy, don't really scale well. And so here's a really classic example. Most security technologies, especially stuff that was born from kind of the legacy data center, physical, on-prem mental model, require a static rules-based approach. So what happens is you have these security tools, these legacy tools that were really, born from security when you were managing physical servers. They try to like port this technology to AWS. And it's very much like trying to squeeze a square peg into a round hole, or a round peg into a square hole. I'm working on the metaphor game, man. I'm working on it. So you've got the static rules-based approach. Most security tools rely on some kind of static rules-based approach. Most of the cloud native security tools like AWS GuardDuty, for example, require a static rules-based approach. And what does that mean exactly? Basically, your InfoSec engineers, your DevOps engineers are going to write rules to try to determine what good behavior is and what good behavior isn't in your environment. Now, here's what's going to happen. One of two things is going to happen. You're going to write too many rules. You're going to write too many rules. These rules are going to be restrictive. You're going to get a ton of false positive alerts. normal activity, maybe a developer trying to deploy a new microservice or setting up a new testing environment, for example, is going to get flagged as suspicious. And then, of course, the inverse is very much true. It's the one rule that you don't write that's going to represent a legitimate indicator of compromise, and you're going to get hacked, right? When you think about static, rules-based, signature-based approaches to cloud security, it's like trying to predict the future. And I really geek out on this stuff. I think it's a fascinating problem set. I've learned a ton over the past couple of months, as it relates to cloud security. And when you think about how sophisticated attackers, Sam, when you think about like sophisticated attackers today, they're compromising systems in novel ways each and every time. Pause for questions.
So what I'm envisioning in my head right now is that, once upon a time, you had a fairly limited set of, servers, entry points, software systems, users, and you could get by having a static list of rules, if then statements, right? If you look like this,
exactly.
pass in.
Exactly.
And so, but what we're in the situation now is the security surface area, if you will. All of these things has been increasing at an accelerated rate. So it's sort of increasing sort of asymptotically even.
Precisely.
While the rules-based approach only really enables you to scale linearly. And so you end up with a lot of unpredictable exposed surface area. And I would imagine, you can correct me if I'm wrong, but also the reverse of that might create situations where things are too restrictive.
Precisely. That's absolutely it. Very well said. And if you were to kind of build on the expansion of the surface area metaphor, it's almost like a fractal, right? I mean, the surface area continues to grow, but the edges and nodes become more acute and more complex, if that analogy makes any sense. Absolutely. One other thing to note is that there are a number of other security vendors in the space. The space is blowing up. It's an incredibly exciting space to be in, because more and more companies, their entire, not even just like part of their business, like their entire business model relies on cloud native technologies. So security, for obvious reasons, is our lives as we become more reliant on technology. Securing digital assets becomes more important proportionally, right? That makes sense. So there's a number of security vendors in the space. There's a lot. It's a very hot space, for lack of a better word. Most of these vendors, if anything, can solve one particular part of the problem. Okay, that's another kind of state. That's another very important aspect. When we think about the cloud security conundrum, is that okay? So we do have tools out there that maybe can address one particular piece of the problem, and some of them can do it okay. Full disclosure, some of them can maybe do one thing well. Snyk, for example, has a really strong story as it relates to vulnerability management and discovery, right? And think back at Circle, right? What people are doing. Are you familiar with the shifting left kind of paradigm, incorporating application security into your CI pipelines?
Yes, I remember that well.
Yeah, really interesting stuff. So what more organizations are doing is they're incorporating application security, they're shifting left, and they're baking it in at earlier and earlier junctures of the software delivery lifecycle. Cool, really interesting stuff. So a very critical component of that is this notion of vulnerability management discovery. We want to find vulnerable packages early on. We want to remediate these packages. We want to keep our containers very lightweight and clean with the latest and greatest, most up-to-date libraries and dependencies. Snyk, for example, has a pretty strong story there, right? But when you think about cloud security holistically, that's really just like one piece of the puzzle. That's just one piece of the puzzle. And so what organizations, they find themselves in this scenario where, okay, now we got to cobble together 10 different tools, 5 different tools, 10 different tools, 15 different tools, ultimately to codify our cloud security posture. Sam, think about, our time in the trenches together at Circle CI, tool sprawl is a very real thing, right? And so now you've got all this operational overhead, you have all this cognitive load. And Sam, managing relationships with 10 different vendors, I don't know, not everybody is as nice or as friendly to work with as the good people at Circle CI when we were working together. So at best, organizations, they cobble together a mismatch of tools, different APIs. If you're really trying to stitch these different tools together, you've got 10 different APIs you're working with. And you know what this leads to? This actually worsens your cloud security posture. That's what the research indicates. This actually undermines your cloud security posture because you don't have a single pane of glass, right?
Makes sense. So this is all laying a pretty robust foundation. I am on the edge of my seat. I have to know what Lacework does at this point.
Cool. So let's dive right in. Sam, blink if you can see my screen. Cool. So we're a cloud native, cloud security automation platform. Our bread and butter is ultimately threat detection, intrusion detection. And obviously I have a bit of a bias given that I work at Lacework. What we're doing in this space, especially as it relates to host intrusion, to threat detection, to anomaly detection, is truly differentiated. There's nobody else in the space who has a solution quite like ours. And so we start here in the dashboard, we start here with the data, because our approach to cloud security is fundamentally different. We treat cloud security as a data problem, right? That underscores everything we do as a platform. Spoiler alert, because we are treating cloud security as a data problem, and we're going to get into where some of these different data sources come from. We use unsupervised machine learning. We have a crazy sophisticated backend where we use unsupervised machine learning to automatically detect anomalous behavior in your environment. That's the crux of our solution. But what this does is this actually solves 4 core use cases as it relates to cloud security. Just want to pause and talk about supervised versus unsupervised machine learning. Sam, are you familiar with this distinction? I imagine some of the folks watching this video might not be. Unsupervised machine learning as it relates to supervised machine learning. Supervised machine learning says, I have a bunch of data and I have a rough idea of the shape of this data, the structure of this data. It's almost like having a key, if you will, and I want to take structured data and I want to derive meaningful insights from structured data. Unsupervised machine learning says, I just have a ton of information. I have no idea what to do with this information. I have no idea how to make sense of any of this information. Take unstructured data and make sense of it. So again, when you think about how attackers are compromising systems today, sophisticated attackers, they're doing so in novel ways each and every time. So that's why taking the unsupervised ML approach to this problem set ultimately makes the most sense. So we start here with the data. We ingest data from 2 primary sources. This is going to be your cloud API. So if you're using AWS, for example, AWS CloudTrail. CloudTrail is a really handy feature. It basically keeps record of any time a principal, an entity, a user logs into AWS, accesses a resource, spins up an EC2 instance, sets up an S3 bucket. CloudTrail keeps record of all of this. If you've ever spent any time, though, trying to make sense of CloudTrail data without a tool like this, it's really, really challenging. It's just basically unstructured logs, terabyte or, well, gigabytes. In some customers, it could be terabytes, but, a ridiculous amount of unstructured data. Trying to make any sense of that, it's nigh impossible, right?
Is it really completely unstructured? Is it like JSON or something like that? Or what's the format?
It is structured, yeah. But, if you don't know what you're looking for and you think about, what are kind of the search parameters that we would want to build alerts or rules off of, it's crazy complex. It's crazy. Oh, go on.
So my understanding is, so this falls under the area of audit logging, right? And folks will often ingest these logs into, big fancy platforms like Splunk.
Exactly.
And then they set up alerts around those things, right? So what is Lacework doing? I'm thinking back to the beginning of the conversation. You're saying that I think Splunk would fall into the realm of like creating rule sets and tripwires, right? Tripwires. And so in this case, you're sort of avoiding that because you're letting the machine learning do the heavy lifting of basically just taking all of this data and telling you, what do I need to pay attention to at any given point in time?
Precisely. That's exactly it. And that's a really good point. A lot of organizations who aren't using a tool like Lacework, for example, they're sending this information. And that's what CloudTrail is. It's your AWS cloud security audit. They're sending that to either Splunk or Sumo Logic. Also, just want to pause real quick. That can get very expensive very quickly because all of these platforms charge on ingest, right? They're charging on the volume of data that you're sending to these platforms. And then, yes, on top of that, you're going to try to build some rules. You're going to try to set up a couple of tripwires. And in some circumstances, that can work okay. But the larger your organization gets, your costs are going to grow exponentially. And the challenge associated with writing more granular rules, more and more tripwires becomes increasingly untenable, right? So we're pulling all of this information from CloudTrail, for example, or from like AWS config. We're going to inventory all of the resources you have in your AWS environment. I'm going to keep using AWS as an example, but we also work with GCP and Azure, full disclosure. Because we can see the resources you have in your environment, we can also look at the corresponding configuration. So we can generate alerts on, very simple example, don't have security groups that are overly permissive, don't have S3 buckets that are open to the public internet. Second primary
that's a huge source of like a lot of hacks is just people leaving unsecured S3 buckets. It's pretty wild, like how many I've seen that are in that.
Yeah. Misconfiguration across the board is absolutely huge. Yeah. Second primary data source we ingest information from is going to be your runtime environments themselves, whether or not it's an EC2 instance, a Kubernetes cluster, an ECS cluster. Buzzword. We would install a very lightweight agent into your environment. And what this agent does, it's a super lightweight, it's a Go binary, super lightweight. All the agent does is take information and send it back to our cloud platform, where again, we let the power of automation kind of do its thing. The process itself, for the curious, for super technical folks who might be watching this, the process itself is actually called data collector. The agent is just a dumb data collector, but it's going to aggregate information, the process level, at the network level, at the application level. It's going to traverse your proc file. It's going to look at things like PCAP, for example. Here's where things get crazy complex. We're going to look at all of the information from CloudTrail. We're going to look at all of this information from your environment itself, including network traffic, application logs, and we're going to aggregate all of this information together. To do that without the ML background, to do this stitching together a couple of different tools, building a bunch of different alerts would be nigh impossible, would be nigh impossible. Sam, does this make sense? Does this resonate with you? Is this something you're excited about?
It does. Let me see if I can predict where this is going. So basically you have all this data coming in, and what the machine learning models are able to do is you have such a overwhelming sample to draw from of what normal looks like.
Precisely.
That when something becomes abnormal, it's able to be flagged immediately.
Precisely. Yeah, that's exactly it.
And again, I'm guessing also, Lacework being a security company and specializing in the space, you probably do have some other elements to this algorithm where it's not only that it's abnormal, but it actually looks like it matches a pattern that looks nefarious. So it maps onto something more urgent.
Yeah. Excellent call out. One thing I also just want to point out real quick is, a lot of prospective customers, they ask if we're comparing their data against other customers' data, for example. We're only comparing individual customer data against their data. We're comparing you against you, if you will. But you make a great point, and I see where your head is at. Another thing to consider is that in addition to the automation, we subscribe to what are referred to as high fidelity threat intelligence feeds. This stuff is really, really interesting, very complex, but basically there are threat intel feeds out there that keep track, very much like the CVE database, for example, of known bad IPs, known bad file hashes, known bad domains. And so anytime we detect that kind of behavior in your environment, for example, let's say somebody plopped in a binary that has a known bad file hash associated, like a crypto miner, for example, that stuff would be immediately flagged.
So, okay, so the platform highlights these things, and then I'm guessing there's an API that would trigger actions in other systems as a result.
100%, yeah. And so that's a great segue. We're gonna run through two events today. Based on everything I told you, you can very much you can compartmentalize the core use cases we solve for is account security, right? Like what principles are taking what actions in my cloud environment, and then the workload and the runtime. Okay, now in my environment, what does normal behavior look like as it relates to the connectivity between different resources? What does that connective tissue look like? But to just draw a distinction between what we can do in an agentless fashion and then what we can do with the agent. So let's just blast through a couple of sample events right here. This is actually one of my favorite. I think it's really, really interesting, especially given the proliferation of crypto mining attacks that's happening these days. Also, whatever alerting channel or mechanism or process or structure you have in place currently, we can very seamlessly integrate with that. PagerDuty, Slack, Splunk, etc. So we have an alert, and what we see here is what we refer to as the dossier. right? So when you think about an alert, a security alert being generated, what are the elements needed to investigate this event, right? And that really comes down to the 4 W's: the why, the who, the what, and the when. And so immediately we see this application, Hydra. Hydra sounds kind of nefarious. Running on this host as user Ubuntu, instantiates an SSH connection to this host as user root. Well, Sam, if you recall, first couple of years I was at Circle, I was a full-time SRE. Whenever people are poking around production resources as root, probably something I'd want to be notified about. When we click on what, though, we're able to start to put together a more comprehensive picture of what's happening. And so here we see all of that meta information, again, that we would need, the elements we would need to surface to make sense of an event like this. Also, a sophisticated attacker would probably name their binary something other than Hydra, right? So it's not any one thing that happened in this particular event. It's a chain of behaviors in the underlying context. And so what we see here, more meta information, host name, external IP, instance ID. If this were a legitimate attack, probably the first thing I would do would be to terminate this resource, disassociate the security group, cut it off from the, from my ecosystem. I can filter on command line args down here. And Sam, can you see this okay? Let me know if you want me to make it bigger.
I can see.
Beautiful. So what you see here, when this application Hydra was instantiated, and Sam, this is what I run through in the demo pitch. I'm going to show you a pretty extreme example. When this application Hydra was fired up, it was passed 2 command line args, one username.txt, and then the other 10 million password list top 500. So this was a brute force application used to brute force privilege escalation. If we go down here, this is something, when I first saw this, when I was learning more about Lacework and thinking about joining, this is a really handy feature. It's called the polygraph. Here we get the nice visual representation of the different elements at play. And so what I'm actually going to do this filter up here. So here we can see where the person logged in from. They logged in is the Ubuntu user. They ultimately instantiated root access. They connected over SSH to, do you recognize these? A couple of crypto mining domains, right? And so what I normally ask folks if I'm doing a legit demo and whatnot is if an attack vector like this were present in their systems today, would you be able to get alerted? It's very interesting. Most organizations, I would say it's a 60-40 split. 60% could get some kind of alert on this today, but the investigation would be very arduous. It would be very manual. Truth be told, about 40% of the organizations I speak to, if this particular scenario were to unfold, they would have no visibility here.
Because I would have to guess that some part of that 60% might be speaking from an aspirational perspective, more so than a very realistic one.
Probably. Yeah, absolutely. And Sam, I encourage everybody actually who hopefully is watching this, think about what are the elements, if we were to use a static rules-based or signature-based approach, like what are the elements that we would be alerting on? Would we be getting an alert every time somebody connected to a box as root user? Well, think about Bear on the SRE team. It's part of his routine job, logging into resources, updating patches and whatnot. Do we want to get an alert every time somebody connects to one of these particular domains? We have to keep record then of all of these known bad actors. That stuff, again, operationally intensive, manual. But anyway, before I digress any further, thoughts, feedback?
Is there much tuning that goes into this? So, for example, can you increase or decrease the sensitivity level, if you will, based on the context?
The ML is very much hands-off. I make the joke that it works right out of the box, batteries included. But what's really handy about a tool like this, in addition to just the incredible surface area, the problems that it can solve, is it alleviates most, if not all, of the manual work associated with tuning the rules, tuning the signatures, tuning the technology itself. For new customers, and Sam, given kind of the work we did together at Circle, it is crazy easy to get set up. The agent you can install in 30 minutes. In the account security piece, you just run a Terraform script that sets up a cross-account read-only role for us to be able to ingest the logs. That's it.
Wow, that sounds so easy, Chris.
That's it. Yeah. Well, yeah. I can think of a couple other pieces of software that are a little bit more. I'm not going to go there. More moving pieces. More moving pieces. So. We're going to move to another event now. This event is more on the account security piece. And so what we see here, high severity event, new AWS user created. Okay, stop, pause. I probably don't want to get an alert every time a new AWS user is provisioned. I don't know, Sam, maybe you do, maybe you do. I'm going to click on this. We're going to get a little bit more information about this event. This one is exciting, Sam. So hold your horses, get excited, get fired up. This is where the power of the polygraph is super, super, super valuable. So what we see here is a principal, an IAM user, aptly called Demo Dev Dave, logs in from Tokyo, Japan for the first time. Okay, that unto itself, not terribly suspicious. Maybe they're on vacation. In fact, you were in Tokyo, what, 2 years ago? Amazing. All right, so, that unto itself, not terribly suspicious. Maybe they're on vacation. Maybe they're a digital nomad. What happens next, though, is very interesting. So Demo Dev Dave logs in from Tokyo for the first time. This is the first time they've accessed an API, the AWS API from this geographic locale. They access IAM, Identity and Access Management. And what they do next is very interesting. So they create a user, they create a set of access keys, the new user aptly named Jay Smith. And then what Jay Smith does is ultimately read data from an S3 bucket, pull data from an S3 bucket, and then Demo Dev Dave, as you can see here, deletes the access keys, deletes the user policy. So what's really interesting about this scenario is what we see, well, spoiler alert, Demo Dev Dave's credentials were compromised somehow. What we see here is once the malicious actor had access to these credentials, they were able to perform a fairly sophisticated exfiltration attack, whereupon they provisioned a new user and then they deleted that user, right? So even if you were thinking about pulling this information from CloudTrail, you're stitching together information from two different AWS services. What you see here is very subtle, but very interesting lateral movement across a couple of core AWS services, whereupon the principal ultimately then obfuscated their tracks. And so when I ask a lot of prospective customers, okay, well, if something like this were to happen in your environment today, could you get alerted? It would be challenging. This particular threat vector right here, I find most organizations have this presents a big challenge for most organizations. This is what you would classify as UEBA, User Entity Behavior Analytics, account security. One thing you'll note, Sam, in the cloud security space, there is a ridiculous number of acronyms. Now, on one hand, it's important for disciplines to have specialized nomenclature, but on the other hand, it's wild, just the overwhelmingly large number of acronyms in the security space. But yeah, this is an account security threat vector. Most organizations I speak with would have a tough time getting alerted if something like this were to happen.
SIEM, IAM, IDP, SSO. Yep. Yeah, I'm familiar with the alphabet soup.
CWSP, CPPA, SSH.
This was very impressive, Chris.
Cool,
not gonna lie. Now, I don't have a huge frame of reference for like how this compares to other solutions on the market, but I mean, based on your narrative here, yeah, it looks like a very strong platform. And I actually like the idea that you don't tune it. I think that's sort of the next phase, right? Phase one, like you mentioned, manual. You create rules. Phase two, I don't want the rules. You tell me what I need to pay attention to, right?
Yeah. I guess in closing, it's our ability to detect anomalous behavior that is truly unparalleled. And again, this is anomalous behavior in your, in the account space with regards to the different users, what resources they're talking to, the relationship between the different resources in your cloud account, and then the workload and runtime protection we provide. It really is unparalleled. It's really exciting stuff. There's nobody who has an approach is differentiated or frankly as sophisticated as ours. And it's kind of like my dream job. I'm super stoked to be here. I'm really happy. And I think it's just a fascinating problem set.
Well, I'm stoked for you too, Chris. They really lucked out when they got you. You're the best sales engineer I've ever worked with. So kudos. Thanks for taking the time.
Cool. Appreciate it, brother. Hope all of you found this valuable. And thank you so much for watching.